Oh, things are getting serious. Find the derivative of f of x equals 2x squared plus 3x using the definition of the derivative. Well, if I give you f of x, then we would call the derivative f prime of x. But what is the definition of the derivative? Well, it's the same thing as instantaneous rate of change, of course. The limit as h approaches 0 of f of x plus h, like that, minus f of x over h. So what we need to do is we need to find out what f of x plus h is, right? We have f of x, plug stuff in, hope things disappear, and wish for the best. F of x plus h means I'm going to take f of x and replace every x with x plus h. So u become 2 times parentheses x plus h, close it, square it, plus 3 times x plus h. Okay? Now, this is a perfect square trinomial, so the 2 remains out there for now. X plus h squared becomes x squared plus 2xh plus h squared, right? Distribute. So you become 3x plus 3h. And then when I distribute the 2 to all of that, I get 2x squared plus 4xh plus 2h squared, and then 3x and 3h come along for the ride. We already know what f of x is, so I'm not going to bother writing it down. So what I'm going to do is I'm going to rewrite this guy out, okay? The limit as h approaches 0 of f of x plus h, so I'm going to write that in blue. That became 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus f of x, which I underlined in purple, so minus 2x squared plus 3x, close that, all over h, like that. Okay, let's distribute that guy. So limit as h approaches 0, nothing in blue changes, nothing at all. I'm just rewriting it out like that, like that. Distribute the negative, minus 2x squared minus 3x. And when you have polynomials like we have here, you're hoping for stuff to disappear, which is going to happen now. 2x squared, adios. 3x, adios to you. And you're left with the limit as h approaches 0 of 4xh plus 2h squared plus 3h over h. Now notice all of these guys have h's, which means I can factor out an h. When you're dealing with polynomials like what we have up here, expect that to happen every single time when we have polynomials. Not every single problem, but every single time when I have polynomials. If I have an h, bring it out. 4x plus 2h plus 3, close it, all over h. See, the initial problem, by the way, is like when I got to this point after I plugged stuff in, if you're like, why don't we just plug in 0 for h? Well, you get 0 on the bottom. That's no good. But now h crosses out. And we are left with the limit as h approaches infinity of 4x plus 2h plus 3. So all I have to do here is replace h with 0, and I get 4x plus nothing plus 3. So after all of that, f prime of x equals 4x plus 3, which is b, baby. Wasn't that fun?